the link down here is basically to the design.ros2.org site, which basically has all of these different articles that describe it. But in particular, this changes one, I think covers quite a bit around this not having a ROS master. The other cool thing that this, I guess, falls under the new features that are awesome is that basically by default, all parameters are dynamic, right? In ROS1, there was this sort of dynamic reconfigure system that was very much built as an afterthought. And so what ended up happening was that you often got nodes where it was like super complex behavior because you would load things from a parameter and then dynamic reconfigure would change them afterwards. And you never really quite knew like what setting was taking place. The names got out of sync very often, a very common problem in the ROS navigation stack, that the parameter name in dynamic reconfigure didn't match the parameter name that would come from a launch file at startup. And it was really tough to debug. So that all goes out the window in ROS2. There's no more dynamic reconfigure. Effectively, every node has these parameter services and parameter events. And so you can actually set all parameters by default can be set over these services at runtime. The other change is to make this so that it can actually happen, right? You might remember in dynamic reconfigure, you had to write out very verbosely everything like this is my parameter, this is its type, all of these sort of things. At least at a minimum in ROS2, you have to declare your parameters, right? So you can sort of see here, like in Python, you would basically take your node instance and say declare parameter, give it a name, and give it a default value. And then, within the service callback, you can basically set up to limit the range of those values and whatnot. The really nice thing here is there's also, because of these services, you can basically do like a ROS2 param list and get a list of all the parameters from all of your nodes or give it a specific node. And so figuring out like what parameters there are in your system is a whole lot easier in ROS2. And so I think that's a big win over ROS1. Build system. Again, we started way back with ROS build. It was this mess of Python and CMake, and I think you had like CMake calling Python, calling CMake, calling Python in some infogations. Catkin was pure CMake, which is a move in the right direction. Ament is basically the successor to Catkin. To a large extent, many of the various calls that you have throughout, if they were Catkin something, they become Ament something. But there are some little bit differences in like how you export libraries to downstream packages and whatnot. Basically, this is meant to be a little bit closer to pure CMake and make it so that there's not as much sort of fancy stuff happening under the covers that's hard to debug. There's also no devel workspace in ROS2 with Ament. So there's no more like just build it and run that. You do have to put install directives in your CMake lists. You can though at least do this. Colcon is actually the tool that you end up calling Ament with. But you can do this colcon build symlink install, which will basically symlink to all of your Python and your launch files and things like that, so that you don't have to like rebuild every time you change a file. You only have to rebuild when you change C++. So that's super useful. And because it is sort of based on pure CMake, you end up needing to use more like fine packages throughout it. So the CMake gets a little bit more verbose. And has some updates. I'm not going to go super in detail into that tonight, just because it's really getting into the weeds to get into that. But I will point out some resources towards the end. One thing that actually a number of you may be very interested in is that there is pure Python packages in ROS2. So if you hate CMake and you only write Python, you can actually just put everything in your setup.py and have a pure Python package that's still a ROS package. And so that's really nice for Python developers. It also makes it a lot easier for those packages to be like released to pip or something like that, if they don't have too many dependencies that are in the ROS chain. Yeah, another big difference, if you ever use nodelets in ROS1, right? Nodelets were a way in C++ to put multiple nodes in a single executable at runtime. Nodelets were, again, kind of like dynamic reconfigure, something that was an afterthought, and they suffered because of that. So for me, one of my biggest complaints with nodelets was always that when you loaded a whole bunch of things into nodelets and you were trying to debug like what was going on, everything got like blended together. And so if you did like a ROS node info on your nodelet, it didn't have the right information, right? Everything would end up in the manager and whatnot. That's not the case in ROS2. They have this new components approach that allows you to load multiple nodes into a single executable at runtime, but they still have the introspection working correctly. And so I've actually got an example of like how to create a component and actually also create an executable that goes with that in this ROS2 cookbook on GitHub. And I'll show that in a little bit, that cookbook. Yeah. Another really big difference in ROS1, when you're doing ROS launch files, they were just XML. In ROS2, ROS launch actually supports XML, Python, and YAML for specifying your launch files. That said, like, you can kind of mix them a little bit. There's support for like having Python launch an XML file, include an XML file and whatnot, but I would really recommend, I don't know that that's super well tested. I would recommend sticking with a single approach. Most of the documentation that you will find is using the Python interface because it was the first one done, or the first one mostly implemented. It can be a little verbose, but I actually, like, it's much more powerful, I think, than any of the XML was in ROS1. And so basically you end up, generating like a launch description where you can list out this whole list of nodes and do all your parameters and your remapping and set up all sorts of things. And basically now you have a Python file that basically defines your launch system. This also allows you to do control over like the order that things come up and stuff like that. One of the things you couldn't do in ROS1 at all. So it's definitely interesting and a lot more powerful. So there's a lot of difference. What are still the same? It is still mostly C++ and Python. Again, there's lots of different client libraries out there, but the best maintained ones are going to be the C++ client library, which is RCLCPP, and the Python one, which is RCLPY. But because they're both based on this core C system and they were developed at the same time by the same team along the way, and it wasn't sort of split up a lot, they have much better feature parity, right? So if there's a feature in RCLCPP, it's almost certainly in RCLPY. And the way that they operate is very similar, right? The threading models are actually the same as opposed to ROSPY and ROSPY and ROSCPP, right, in ROS1, had entirely different threading models, and you had to know what was going on with them. Here, it's much closer. It's actually the same, and as you set things up, it just works similarly. There's still also a lot of command line tools. In ROS1, they were all basically one word: ROS node, ROS topic, etc. In ROS2, basically, there's this catch-all command called ROS2, and then it takes as arguments different verbs. So ROS2 node list, right? ROS2 topic info. And then they actually work pretty much identically to ROS1. So all that time you spent learning command line tools still works here. Yeah. And that was literally my one slide on like what's the same. Yeah, so quality of service. Let's talk about this because this is a really big change. So quality of service is basically defining how you want your networking to work. So in ROS1, you basically, when you set up a publisher, you could basically set this queue size parameter, right? And that basically said how many messages you would hold on to in the publisher. And you would try and send those, but if like they got backlogged or whatnot, you'd start dropping old messages when you got to your queue size. So typically if you were sending really big messages, like say images, you might set the queue size to 1 and basically say like, look, if you can't get this one out by the time there's another one ready, just drop it and move on to the next one. And So basically you just had queue size and you had latching. Those were pretty much the only things you had in ROS1. There was a UDP mode, but it was only in C++, and it wasn't very widely used or tested. So quality of service in ROS2, there's obviously a lot more going on here. So you have history and depth, which is basically setting, those are two parameters that work together to basically set how many messages to keep and what the policy is around keeping them. And so this is sort of a more advanced version of the queue size that you had in ROS1. You also have this reliability, which is best effort or reliable. So reliable basically means if you drop a message, it's going to sit there and just keep trying to resend it. Best effort means you're going to try and get it out there, but like, hey, if it doesn't drop and things are backing up, you're gonna move that through. So within ROS2, most sensors are actually using this best effort approach, right? And yeah, that has a caveat that we'll see on this on the next slide. You also have durability, and these names are kind of weird: volatile or transient local. Basically, the way to think about it is that transient local is basically like latching in ROS1, right? So if you set it to transient local, say for instance for a map, right? Like you have a map message, basically once you've loaded it up, probably doesn't change, but you want the message to still be valid when a new subscriber comes online, right? So like if I've got a robot that's running and it's publishing the map and I start RViz up, I want to get that map, right? But I don't want to be republishing the map continuously. And so there, like map publishers are typically set to transient local, just as they would have been set to latching in ROS1. There's also some other lesser used parameters, or at least lesser used in my experience so far, of deadline, lifespan, liveliness, and least duration. And these are all basically around deciding like how to get messages through, and more importantly, how to deal with unreliability in the network, right? And because that's really the big thing that ROS1 didn't really do a great job with. So you've got all these parameters. Setting each one individually is kind of tedious. So there are also profiles, right? And so one of the profiles is the default, which is basically reliable and keep the last 10 and volatile, right? So non-latching, keep 10 images, which is basically the same in ROS1 as saying like queue size equals 10, which I think was the example that was given for queue size, and 99% of nodes just put queue size equals 10. So you still have that option to just do queue size equals 10 pretty much in ROS2. There's also a profile for sensor data, which is basically best effort with a smaller queue size. And there's a little bit of other tweaking going on in there, but that's effectively the way to think about the sensor data one. And so there is this page about quality of service settings, again, well, this is actually not on design.ros2, this is actually on index.ros.org. And so that's a useful link. And these are two pictures that I pulled from that page, because this is actually the big challenge, I think, with quality of service in ROS2. It's built on top of DDS, and so we have the same limitations that DDS has internally. And in particular, there are incompatibilities between various QoS policies. So if you have a publisher that's publishing in one way and you have a subscriber on the other end that's set up wrong, you actually can get certain scenarios where no messages come through and there's not really much of an error message. Like depending on what you're in, like RViz will actually publish a little message to be like, hey, this isn't working. But not everything is actually publishing something like that. And so the one to look out for basically is that if you have a best effort publisher and a subscriber that is set up for reliable, it's not compatible, right? Because your publisher is saying like, I'm gonna throw out messages when I can't get them through. Your subscriber is saying, send me all of the messages. That just doesn't jive, right? The other one is also if you have a volatile publisher and a subscriber that is saying basically, hey, I want you to do latching, that doesn't work either. And so I'm actually going to do a quick demo here to sort of show what that looks like with one of these, not the transient local, but the other one. So yeah, so this is RViz on a Mac. So that's kind of cool. I don't know, I really am interested in that. And I'm going to go ahead and add a camera topic here. And so I'm going to actually put in points from, no, I want from depth down sample because I don't want to spam this a lot. And so nothing's showing up at the moment, but if I come over here and basically do a drop down under topic, we actually have the ability to change these settings. So I can actually change this to best effort. And now everything's starting to show up because it's publishing best effort, but I was set to reliable, which is one of those the one scenario that doesn't work. And so now I've got my depth image publishing, and if I move my arm, you can kind of see it in that image. So yeah, so it's very easy at least to adjust these things in RViz. It's a little bit more challenging when you have nodes that are connecting to each other. There's work going on right now to sort of have a common infrastructure for setting this the same way you set parameters, so that you could specify your quality of service for all of your nodes when you're starting things up. Okay, let me bring this back. So RViz2 on a Mac, connecting to a robot, that's pretty cool. Okay, so I'm gonna kind of go through a little example of like what this looks like, just so that you've got an idea. So I guess one of the other big changes is obviously Python 3 only, right? Python 2 is dead, but not quite. Certainly like ROS Noetic just went out, is the last release of ROS1. It supports Python 3 on Ubuntu 20.04. But Melodic still has 3 years of life left, and it is still Python 2. And for anybody who tells you that Python's completely dead in Ubuntu 18.04, that's actually not true, because the Ubuntu team themselves, while the Python developers no longer support it, Ubuntu itself, because it's an LTS, actually continues to pay attention to security releases and whatnot that they may need to do to patch that. So this is an example of Python 3 creating a node with RCLPY. And so basically, we import RCLPY. We end up doing create a node, import the node class. Message imports look exactly the same as they did. And many of the messages you're used to using, all those common interfaces, they're all the same in ROS2. So that's kind of nice. One of the differences is that the sort of common workflow is basically to create your class as an instance of node, give it the name that basically is the name of your node at runtime. And then basically all of these create publisher, create subscriber, they're not actually methods of RCLPY, they're methods of the node. And so basically that's a little bit more consistency between Python and C++. A lot less globals and things like that going on. But yeah, so we can create a publisher, and I'm using here just that, again, hey, that we talked about it, I don't have to write queue size, right? It's not a parameter anymore. But if I just put 10 there, that is my history depth. Or I could put a QoS object there if I want to set up something a little fancier. And then I can basically do a subscriber. The order of the parameters has changed so that they're common between Python and C++. So you give it your message type, you give it the topic name, you set it up to come back to a callback, and again, you can specify either the depth, right, or you can put a QoS object here. And then you basically have your callback, and so I've actually set up this little very stupid node to basically subscribe to a topic and then publish the same message back out and publish to the logger while it's doing it. And so this is one of those things where big change from Python in the Python side is that in ROS1 with ROSPY, every time you created a new subscriber, you basically got a new thread that was managing that subscriber, right? And so everything was super asynchronous. You got lots and lots of threads. It's actually a problem for people who have like huge numbers of ROS nodes, that you can actually run out of threads if you set your thread limit too low, because a node with 10 subscribers and all of the other stuff going on, you can suddenly have like 50 threads in your Python node. You don't get that as much here with ROS2. Basically, this ends up being sort of single threaded at that point. and you make this call to spin. There's also a multi-threaded spinner, I believe. I know there's definitely one in the C++. I believe there's one in the Python as well. So being aware that the threading is very different. If you try to do something in this callback that blocks, expecting that some other callback is going to get hit, it's not going to work the way it did in ROS1. So that's like a big gotcha in porting your Python from ROS1 to ROS2. Parameters. So yeah, so as we said, all parameters have to be declared. And so here you got this example where, again, I'm creating this node. I'm declaring a parameter with a name and giving it a type, or not a type, but a default value, which also kind of sets its type. And then this cool thing you can do. So this is basically the equivalent of dynamic reconfigure. You can set a parameters callback. And so this is that setup where when you call that service to change the parameters, and you can do it through actually the RQT dynamic reconfigure GUI or RQT reconfigure rather, it didn't have the word dynamic in the name ever, but RQT reconfigure has been completely written under the hood to use these dynamic parameter systems. So it no longer uses dynamic reconfigure, it just uses the actual everything is dynamic aspect. And so it ends up calling into these callbacks. And so the style of how this works is basically you can go through and check all of the things that were sent in. And if you don't like them, you can basically say, you know, false, I'm not accepting this, and return an error message of like why. And so this is how you basically can code in limits on your different parameters, right? And so it's super powerful at the point. You could also do other processing here if you wanted to update things, or at any given time, you can basically just do get parameter with your parameter name and basically get whatever that latest value is. So if you have some loop that's running and you want it to be dynamic and you don't have to apply any limits, you just forget about this whole parameters callback and then just use get parameter every time when you want to get the latest value, and it will automatically work with those services and everything's reconfigurable. So that's, I think, one of the very nice things, and this all works the same in Python or C++. Yep. Some other things, sort of ROSPY to RCLPY, and I put this up here because I actually had a hard time figuring out how this one worked. Right, so in ROS1, you could do rospy.time.now to get the current time, whether you were under simulation or not. Again, it's not a part of ROSPY anymore. Now it's part of that node instance, right? So like an instance of that node class, you call get clock and then call now. But then the one that really tripped me up, and I swear this took me like an hour the first time. So don't, you know, I mean, I'm a ROS1 expert. I'm learning a lot about ROS2. So don't feel bad if as you're working through things, it's like, wait a minute, why is this taking so long? I swear it took me an hour to figure out how to set the timestamp in a message, because basically if I have this T, which is, you know, my return from, say, an instance.getClock.now, which I had, you have to call .to message on it to actually convert it in. And so that's very different from ROS1. And so I specifically added this to a thing because, like, as people who are using robots, timestamps are very important. For people who are just developing on ROS2 and building it out, but not really using it on a robot, maybe time's not as important, but I actually had a really hard time finding an example of this anywhere. And so this particular instance was sort of the thing that got me to go create that ROS2 cookbook, which I'll go back and show off in a little bit. So other features and changes that I'm not going to go into great depth on. There's a big thing called life cycle nodes. So one of the big challenges I think in ROS1 that people run into at various times is that you don't know the order your system's going to come up in. You want to sort of manage everything getting started and whatnot. And so there's this life cycle node system where you can basically set it up so that your node has like an on initialize, on configure, on shutdown, etc. And you can basically do that across this whole set of nodes all simultaneously, right? So you can make sure everybody's configured, and then you can say, okay, go ahead, start. And then you can shut them down nicely. And so this is actually used in a variety of places. The navigation system in ROS2 actually uses it to have a little bit more control over making sure that everything's kind of initialized before data starts piling in. Bag files, very common in ROS1. ROSBAG is very well supported in ROS2 now. ROSFoxy is the latest ROS2 release. This came out back in May or June of this year. It has this nice logo. I actually bought one of their flags to put up. And so I've been using ROSFoxy. It actually has, we've talked about all this problem with quality of service. As you could imagine, if ROSBAG didn't handle quality of service correctly, nothing would ever record properly. And so in Foxy, as a new feature, ROSBAG automatically determines what the quality of service settings are that it needs in order to record from each topic. So that just kind of works out of the box now. So that's a huge improvement. So if you've tried ROS2 previously and lots of things weren't working, Foxy is actually one of those is the release where like a lot of stuff starts to work. There's still a lot of higher level things that are in progress. But like core tools, I think are very good at this point. The other big change with ROSBAG is it actually under the hood uses SQLite. So a bag actually becomes like a directory, not just a file. And so you can actually, you can zip that up afterwards and move it around. But you can do a lot more querying against it than you could with the sort of flat file that ROSBAG in ROS1 had. There's also, I don't know that this is a big seller to Homebrew Robotics Club, but certainly for the industrial folks, it's really big that basically there's built-in security that comes with DDS, right? And so there's this notion that you can sort of say, these are the things that are allowed to listen to this topic, right? And these are the things that are allowed to publish to this topic. And so, for instance, you could allow topics that you want to be able to debug from RViz to get off of the robot, but say, hey, no one can send a command velocity to my mobile base except these certain nodes that are on the robot. And so that's a fairly large feature increase over ROS1. Relatively well documented, but I haven't actually dug into it much. Okay, so I'm going to switch back out of this again and do a couple of demos before I go into more deeper things. So again, I'm pulling up RViz 2 on my Mac. One of the bugs so there's two here that you're seeing with RViz. One is that it takes a really long time to load the meshes in ROS2 in RViz, and that's across Ubuntu and Mac, and I haven't figured out what's going on with that. The other one is that if you don't have a base link for, or if your fixed frame isn't findable, so I don't have a map publishing yet right now, it ends up spinning and eating just an absolute ton of your CPU. So just make sure that your fixed frame is set properly and then go about your day. So I've got my robot out here let me move that. Yeah, there we go. So I've got the robot in the room here, and something I set up that's kind of cool is I've got Maxwell over here on the table, and he's also running ROS2 now. And I have his camera publishing. And so that's coming off of there. The other data is coming off of the robot that's down in the corner. And so that's pretty cool. So let me pull up now. I'm going to do build map. And in a moment, let me make sure. Yep. So there we go. So I'm using Slam Toolbox here. And I just recently posted a blog post up on my blog, robotandchisel.com, on basically mapping and localization in ROS2. And so this is basically going through how I got all of that working in a lot of detail. But you can see, I'm building the map. I've got my PS4 controller here. And there we go. Why is that not going? Okay, well, that's a new one. Yay live demos. What is
like
that?
G-mapping?
Yeah, so this is Slam Toolbox running. I was going to drive around and build a map. I guess I'm not going to because for some reason I can't drive. Oh, there we go. Okay. Thinking this was glitching a little bit. So yeah, like G-mapping or Slam Cardo. If you use Cardo, Slam Toolbox is basically the scan matcher from Slam Cardo. on steroids, very rebuilt. And this has been ported to ROS2 where some of the other SLAM systems have not. And so, yeah, so you've got, building a map, pretty straightforward, once you've got your robot working under ROS2. So I guess there's a bit of a step there. So that's building a map. I'm actually going to kill that map. I'm not actually going to save it and whatnot, because instead I'm going to pull up my pre-built map that's already like ready for prime time. And I'm going to set, just like with ROS1, I'm going to set to the map frame and get this guy. Come on. There we go. And set his pose. Okay, and I can pull up, now I'm gonna start up, so that's localization with AMCL. And so this is all the navigation stack under ROS2, which is using a lot of the same stuff that was in ROS1, right? It's still using the same cost maps and a lot of the same planners. And wow, I've got a lot of noise there, but let's try this out. And then you can send a command and you can see there's actually nothing in front of it, but my sensor's picking up stuff. So in a moment here, it's going to clear those cost maps, or it's just going to fight its way through maybe. Oh, come on. Typical navigation demo, right? Ah, there we go. Now we've cleared the cost maps. And yep. So yeah, there's definitely some sensor noise coming in. I've recently added the head camera in, but maybe not tested as well. And so now you're seeing the lovely recovery behaviors of rotating around. And it's now cleared. And yeah. So yeah, that is, navigation running in ROS2. Obviously I've had this working for about a week and a half at this point. I was anticipating doing this talk in October, and so we sort of moved it up a little bit. So not as polished of demos, but the talk is, I think, pretty well put together. So that is RViz, and I'm gonna stop that now. And we don't need to save the changes. And I'll leave nav running on the robot. Okay, and then let me come back to here. And I forgot to cross this out on here. So I had UBR1 running Move It too. So let's talk about it for a minute. So I obviously do not have this demo. I actually have Move It 2 compiled on the robot, and that's about as far as I got at the moment. There's a lot of things still missing in Move It 2. In particular, the Move Group like interface that everything kind of that all of my existing demos would connect through is missing. There's a pull request, it's in progress, but it's not in there yet. So I haven't actually done anything with Move It 2 yet. So maybe that'll come back as a demo, later this year.
So is Navigation 2 equivalent to Move Base?
Yes, so Navigation 2 is basically the replacement. So there was the navigation stack, which Move Base was the centerpiece. And so it is the replacement for it. Like I said, the planners, the cost maps are all pretty similar. One of the really big changes is that in ROS1, everything was in a single node, right? There was just Move Base, and you loaded all these plugins in for the cost maps and for the planners. In ROS2, they've actually gone to this different architecture where there are actually a separate planning server, controller server, and recovery server, and everything's connected through ROS actions. And then those ROS actions are all actually called through a behavior tree system. So out of the box, you can make it look like navigation did in ROS1. But when you really want to dig into it, you have this ability to really entirely change what the recovery behaviors are that are going on through these behavior trees. And you can sort of set up like very specifically, like instead of just having like a parameter that's like, should I replan or not? You could actually say like, well, I want to replan 5 times. And then I want to try, a clear cost map with this size. And then I want to send a notice. I just saw actually today somebody created a tutorial for sending a text message through Twilio when you've hit a certain part of the behavior tree. And so like as a recovery behavior, it could like notify you that like, hey, maybe there's this problem that you should look at. And so you have a lot of control there at that point. Again, it's much more power, like out of the box, it can be equivalent. But when you really want to dig into it, you could add a whole lot of different recovery behaviors and change how those are being used.
Where's the localizer?
It's still AMCL. So when I was running that, it was the same AMCL. Yep. So I like I said, I have a blog post up so far on doing this mapping portion that sort of walks through everything that's going on with that. The navigation one will probably be up next week. It's about half written right now on sort of what it takes to put that whole demo together. Okay. So that concludes my set of demos for the moment. So we talked about these sort of RMW implementations. I'm going to go into a little bit more detail here. Is that, like I said, there's multiple vendors that have these implementations for DDS. Right now, the default is fast RTPS, which apparently right after Foxy was released, they renamed it to fast DDS. So when you see these two things, they're the same, but you have to use the right name in the system you're in. So like after Foxy, it'll be fast DDS or maybe not. We'll get to that in a moment. And it's fast RTPS in Foxy. But there's also Cyclone DDS, which is actually this newer one that has been basically written from scratch. It's a lot more performant. And it's an Eclipse project. And so it's up and coming and might be the default in the future. We'll see. To switch between these, basically there's an environment variable called RMW implementation. And so you basically set it RMW implementation equals, and the names are all like RMW underscore the name of the DDS underscore CPP, because apparently we thought we might write multiple implementations that are not in C++. I don't know. Anyways, those are the names and that you set. Cyclone, so there are various issues with fast RTPS, particularly when you're over Wi-Fi and things like that. And so a lot of people have started to be using Cyclone DDS. And I've actually been using that as well because I found it fixed a lot of issues that I was running into. There is also, for Cyclone DDS, there's also this Cyclone DDS URI, which lets you basically go in and tune all of these DDS level parameters. So completely separate from the QoS is setting up the DDS implementation to do things. So like I said, there's lots of levers to pull on tuning. It can become very complex. Out of the box, most things should work like from the get-go. There is one note here that like Cyclone DDS right now only binds to a single network interface. So on my blog, I actually have a blog post about Cyclone DDS with lots of details. In particular, I found here that one of my challenges was, while it's supposed to pick the best network interface and avoid link local interfaces, if there's a better one, on the UBR1, it insists, if I don't tell it which interface, it insists on binding to the local Ethernet interface that is connected to the hardware. And so that doesn't get out anywhere. So everything works locally on the robot, but I could never connect to it externally. And so I had to actually set the Cyclone DDS URI. And so I guess these are, yeah, so here's the example there of RMW Cyclone DDS CPP, right? You can do this export RMW implementation to basically enable that. I actually end up just putting that in my bash RC so that it happens every time and I don't need to keep typing it in. And then the Cyclone DDS URI, you can either give it a path to a file that is XML or the actual XML just right there in the line. And I've got a couple of different examples coming up and also on that blog post. The other one to know is this ROS domain ID. So like I said, there's no ROS master. So there's no ROS master URI. So everything talks to everything by default, which sounds like a great idea right up until the first HBRC meeting where there's at least 2 ROS2 robots on the network and none of them, and they haven't done anything to like partition it because they're both going to almost certainly have a base link to map transform. and they're going to compete. So the sort of the least granular level is that you can set ROS domain ID to any number between 0 and I believe 253. So that would work for us as long as everyone agreed on which number they were going to pick. And you have to set it on your robot and then on your desktop as well. And that, again, that works until you've picked a number and somebody else picks it. So I was originally, when I was putting this talk together, I was like, I'm going to claim my number in this talk and tell y'all you can't use my number. But then I actually reached out to the folks at Cyclone DDS, and they were actually able to give me some better ideas. So with Cyclone DDS, so here's that example of an XML file for Cyclone DDS URI. And you can set the network interface address. So this is me setting it to my Wi-Fi so that it makes sure that it binds to the Wi-Fi interface and like I can connect to the robot. So you might need to do that if you have multiple interfaces and it's not automatically picking the best one properly. I guess it decided that the local interface was the best. I disagree. The other one is that a lot of this stuff happens through multicast. Certainly the discovery is through multicast. If you just let it do default, it'll try and multicast a lot of everything basically. And apparently a lot of Wi-Fi equipment doesn't work great with multicast. And so one of the recommended things if you're on Wi-Fi is actually to say for your allow multicast setting is this SPDP, which basically says use multicast for discovery, but don't use it for message transportation. So it'll only be doing a little bit of multicast. And then like when your RViz is streaming topics, those will just be unicast messages coming to you. And so that should be a little bit more reliable on the Wi-Fi. I haven't really tested this head to head, but it's the recommendation from the experts. And so probably a good practice for that first in-person meeting that has lots of ROS2 robots at it. But here's the real trick, is that and this only works for Cyclone DDS, right? Fast RTPS, I don't think has this equivalent tag, but they've added this new tag name. And so basically, if you put this in both of your machines, you can pick an arbitrary string, and only the systems that have that arbitrary string will talk to each other. And so basically, you can have your robot, you know, your personal robots that you brought, you can have your machine that has RViz running on it, and they can both be set to this same tag, and they'll talk to each other, but nothing else will talk to it. And it'll be a lot harder for us to all collide if we all pick, well, as long as we don't all, if we all pick my underscore robot underscore name, it's not going to work. So don't use that example. Similarly, your network interface is probably not WLP2S0. But yeah, pick a tag, put it in there. You can put this in a file. I actually just make it like .cyclonedds.xml, and so it's a hidden file in my home folder. And then you can basically do this export Cyclone DDS URI and give it the path to that file in your bash RC, and it'll just always work. And so then like you don't have to change it when you're at home versus there. You don't have to look up IP addresses, etc. You just don't care because it will automatically work this way. And other people won't be connecting to your robot and stealing it and running away. Okay, so this is my last slide. Basically, so state of ROS2, and this is all obviously my opinion. Your mileage may vary. Other people may have different thoughts as well. And I'm sort of coming from the standpoint of not someone who wants to go in and develop core ROS, which is still the majority of the ROS2 user community, from what I can tell. I'm somebody who wants to just make my robot work, right? So message passing is generally pretty solid, right? Like the things that you would expect to work there work as long as you understand the QoS aspects and deal with little nuances with the networking that can possibly pop up. There are some things that are missing though, certainly. One is lazy subscribers don't exist. And this is a very technical one, but basically in C++, this notion that like, if no one's subscribing, don't do all the work to create the data and send it on. You can't really do right now. There's some missing stuff. I have a blog post up of 5 things ROS2 needs in 2020. I think this was number 1 or number 2, something like that, with a lot more technical detail on it. I think for vision processing pipelines, this is an essential component that's not there yet. And so various things like using like the head camera of my UBR1 is very hacked at the moment, because you can't sort of have the system automatically spin up the topics you need and then have it like shut them down gracefully when you don't need them. It's all or nothing. They're just running or they're not. And so if you're CPU limited, you sort of got to tweak like what the system is for your different application. If you're building sort of a single demo that just goes out and goes for it, this may not be as big of an issue. Depending on what you're using for hardware, not all of the drivers have been ported. So I've ported OpenAI to camera. So if you're using a one of the ASUS sensors or whatnot, like that driver's there. It's not merged yet because it's actually depending on some things that have been merged upstream but not yet released. So there's an issue on OpenAI 2 camera sort of tracking that. There's other drivers that haven't been ported. So I've been porting a lot of drivers. And what I've been finding in a lot of cases is that there's already, in some cases, an instance of a port, might be out of date, might not work anymore, but it almost certainly isn't merged, right? There's a lot of drivers floating around where we don't have a well-supported ROS2 branch. And so there's actually an effort right now on discourse.ros.org where there's a spreadsheet to sort of try and collect all these packages that either still need to be ported or like the ports need to be resolved. And so there's a lot more emphasis on that right now since the release of ROS2 Foxy. So I think that's going to improve a lot over the next year. The mid-level utilities, things like image pipeline, image common, I don't think they're all that well tested yet and in ROS2. And so they've been ported, but like you get certain things. I actually, just to make this demo work, found out like crop decimate was unusable, right? And so I wanted to shrink a depth image before turning it into that point cloud so that I could have that, very small point cloud, 160 by 120 pixels to put into my cost map rather than the full VGA image, right? And it turns out like that cross decimate just didn't work at all because the topics were named the same for the input and the output. And it was something that you would obviously catch if you ever use the nodes. So I think I'm the first person to actually use that since it was ported to ROS2. That's actually fixed, but it's fixed, it's merged, but it's not released yet to the Debians. So some of those mid-level utilities are still buggy, but they're improving rapidly. And then higher level apps are under significant development. Nav is actually, it's still getting a lot of development right now, but I would say the core feature set is all there. You may want to sort of build it from source and then keep that known version, or be careful about when you update your debs. I updated my source branch and in order to pull in a fix that I was looking for, and found out that, and it's fixed now. I opened a pull request. It's building and should be in debs for Foxy in about 3 days or so. That basically Nav2, somebody had refactored some stuff and broken goals. Like the robot would never have decided that it succeeded in a goal because it was comparing the goal in the ODOM frame versus the goal in the map frame. And so unless your ODOM and your map were perfectly aligned, which I guess probably happens in simulation, but not in the real world, you wouldn't have succeeded. So that's been fixed. So there are still bugs in there. And obviously Move It, as I said, is not, there's a demo there. You can sort of run this demo. But it's still missing some of the things that I would typically use for interfaces. And so there's definitely a lot of development to go on with that. And so that's my sort of take on the state of ROS2. So yeah, if you're looking for more information, obviously, there's only so much we can cover in sort of an hour going into ROS2. It's a huge topic. I've spent, I don't know how many hours at this point learning ROS2. And porting software over to it. But you can find a lot more on my blog, robotandchisel.com, and also on Twitter at The Real Fergs. I've been sort of tweeting out every so often various tips and tricks and whatnot around ROS2. Let me move that back over here. So that's in the background. And I'm also going to pull up, so that's the blog that's linked there. I've also got this other, I didn't actually get it onto that slide because it's like, I don't know, 5 days old at this point or so. I created a GitHub repo called ROS2 Cookbook. And so this is me sort of trying to coordinate all of those little snippets of code that you reuse frequently, and you can't seem like they're buried in some tutorial or example somewhere, or maybe nowhere at all in many cases. And so it was this little snippets that I kept finding that I was reusing frequently. And so for instance, like, and I've also got links here to the actual API up on the web, because Google wants to still send you to some like alpha 2 version rather than latest. So these quick links are nice. You know, there's examples on here of like how to use RCLPY time, and, you know, the different little conversions that are needed and why they are. And then I do have a bunch of details up here around all of those same examples. Actually, you'll notice like this example right here that was in the slides basically was a screen grab of what's here in the ROS2 cookbook. And so I think this will be very useful. There's also a bunch of aspects around CMake, as well as linking to the different areas where you can find more information about these aspects. Yeah. Oh, and I guess I should also mention the most important, probably the most important command to know in ROS2 is ROS2 topic info with the topic name. You're all used to that. But well, you're used to ROS topic, right? But ROS2 topic info with a topic name. And if you give it -- verbose, it will give you all of the information about the quality of service. And so if you have a disconnect between the two things, you'll actually get better information. So like if I'm over here and I do ROS2 topic, if I can type list, I get my whole list, and I can do ROS2 topic info map verbose, and you can actually see that you know, it's being published by map server with reliable transport and transient local, as we discussed earlier, right? That's the equivalent of latching. And AMCL is subscribing, and it's doing it right. It's reliable and transient local. And so like those two are making a connection, and everything looks great. So yeah, probably this is new in ROS2 Foxy. So prior to Foxy, I don't know how you figured out what was going on with QoS, but you didn't do it that way. So super helpful command to know. And that's why it makes the front page of my cookbook. Yeah. So that's what I've got. I don't know if we want to do some questions or whatnot, Sam. I don't know. I don't have, it looks like there's a ton of stuff in chat. So I'm going to stop the screen share for a moment so I can actually see the chat and see if there's questions here. Okay, so let's see. Cyclone DDS versus OCI Open DDS. I'm not sure that there's actually a wrapper for Open DDS at this point that's actually maintained. I know Fast RTPS is maintained, RTIs is maintained, and Cyclones is maintained. I don't know beyond that. I know there's other ones that had ports at various times, but may not be maintained. Yep. If you'd like to run ROS2 over the internet, VPN, yep. That's cool. Auto QoS on RViz was another one of my, Rohan, good question. There are no development plans for it at the moment. Unfortunately, one of the big problems that RViz is facing is that it really kind of lacks a solid maintainer team, right? Like the people who are maintaining it do not have the time to maintain it. They're doing it because it has to happen, right? And so there's some folks from Open Robotics that are making sure that things get merged and released and whatnot, but they don't actually have time to be doing development on it. And so a lot of the development you see going on with RViz is basically community driven. And so I actually recently put in some stuff to like fix it so that, you know, when I put it on my Mac, like dark mode shows up properly, because like that's the level of fix that I'm going to work on at the moment. But yeah, auto QoS was definitely that might actually been my number one. I think actually, now that I think about it, on top 5 things that ROS2 needs in 2020 or in 2020. Let me go to, I can actually do this of ROS2, and yeah, 5 things ROS2 needs. Yeah, automatic QoS for RViz and the command line tools was the other one that they don't necessarily have it. And so you may, if you do like a ROS2 topic echo, and it just does the default settings. And so obviously it won't echo certain things. So I think that's a much needed improvement. I don't believe that anyone has committed the time to do it. It's one of those things that at some point I may take a look at, but after I'm done porting like the other 50 packages that I have on my list, various things that I maintain and whatnot. Yeah, SQLite. Yep. Gmapping is an unmaintained status. So in ROS1, so the same SLAM, I had a question here about Gmapping is unmaintained. What's in ROS1? So I'm actually the maintainer of SLAM Cardo, which I find just out of the box works very well still in ROS1. We have no plans to port it to ROS2 because again, like I said, a large portion of it is in SLAM Toolbox. SLAM Toolbox is also in ROS1. I think there's a little bit more setup than SLAM Cardo sometimes. And Cartographer is, yeah, Cartographer does work there. It's also at the moment largely unmaintained in both ROS1 and ROS2. Basically, there is no more Cartographer team, I guess, at Google working on it. And so it is exactly what it is, but if it breaks at some point, I don't think anybody's going to be there to fix it. Yes, that's what happened to all the insects that you were hearing. I closed the window. Let's see. It's possible. Cool. Yeah. SLAM Toolbox is definitely maintained. Steve McKenzie has been doing a lot of work on that. Definitely in ROS2. I don't know that he's doing a lot of work on it in ROS1, but it works there. One note, you can't have both SLAM Cardo and SLAM Toolbox installed at the same time from Debian's because they actually install the same library, because there is very much, it is Cardo Scan Matcher in SLAM Toolbox because it installs to the same library. So if you run into that trouble, you got to uninstall one to install the other. You can, so there's a comment around namespacing. So you can, the tag is basically who talks to each other. And so like that'll limit the topics and whatnot so that you're not getting messages, because you wouldn't want TF messages particularly from other things. There is also the ability to sort of namespace. So I'm not using it right now, but if I want multiple robots on my network at the same time and I want to be able to connect to both of them from RViz, you can actually do that, and you can basically namespace the whole like launch file that brings up the robot and push everything into a namespace. So that like all their TF frames would be namespaced and all of their topics would be namespaced. And so like I would have like UBR1/base scan and Maxwell/base scan, and I could choose between them appropriately. So there is definitely that support there with the ROS launch. Let's see. Are there consequences of disabling security on the Mac for ROS2? So I actually have made, I know the documentation tells you to disable the security, the system integrity protection. I have not disabled security and the system integrity protection. And I've been able to make everything run, with the exception of there's some little bit of workarounds, like if you want to run things in GDB, or if you want to run some Python nodes, you got to make sure that you use a Python that's outside user lib, right? And so it's got to be something that's in user local or somewhere else, so that it's outside of the system integrity protection. But I think it's very realistic to have ROS on the Mac running without disabling system integrity protection. And I did talk about that I have a blog post up about ROS2 on the Mac, in particular, ROS2 on Mac OS Catalina, right, which is the newest release, which is, and by newest, by like, you know, it's Mac of the last year and a half or so, I think, right? But it's not actually officially supported for ROS2, but I found that almost everything works fine. If someone is using ROS1, is this a good time to migrate to ROS2? I think the thing to look at is what dependencies are you using? Are they ported, or have you found a port that is sufficiently working? And if not, how tolerant are you to basically porting various low-level dependencies that you're using? You know, I've ported a lot of driver stuff over, and I found various things where like it was ported but no longer actually worked. So like I have a Hoyo laser in both of my robots, and the erg node for that like was ported a long time ago and actually was refactored as a component. And during the refactor, they kind of messed it up, and it just flat out didn't actually start, right? Like the node was running, but it wasn't actually ever communicating with the Hoyo. So I ended up fixing that bug, and then I actually ended up taking over maintainership of that package because that was how to get it merged and get it released. So if you have tolerance for that sort of thing, or if everything you're depending on is already ported, ROS2 probably has a similar out-of-box experience as ROS1 at the moment, right? Like a lot of the stuff just works. You may have to dig into a little bit of this networking along the way, but you may not have to. So I think it's, if you're very familiar with ROS1, I think it's time to look at ROS2. Migrate may be a different discussion, right? Like take a look at what you've got, what's out there, and how it's going to work for you. Do tags work across DDS vendors? So technically the tag is, oh, and actually let me back up. There was one other related question was, if you're just getting started with ROS, should they use ROS1 or ROS2? Unfortunately, because of the amount of documentation out there for ROS2 and the fact that it's just spread all over the internet at the moment, right? It is easier to learn the basics of ROS1 and then probably take like this presentation to translate it into ROS2. If you jump straight into ROS2, there are some tutorials, but it's sparse, right? And so you could end up trying it out, but I have a feeling that if you've never used ROS at all, if you jump straight into ROS2 today, you may be more frustrated than if you jump straight into ROS1 today. Yeah. Do tags work across DDS vendors? So my understanding is that the tag has been added to the DDS spec, but it is relatively new, and I do not know that anything other than Cyclone actually follows it. All of the DDS vendors support the ROS domain ID, like that's universal, but I don't think the tag part is universal. It probably will be eventually, but again, if you're using DDS if you're using Cyclone DDS on both ends, it will work. Yeah. What do you think the level of effort is to port ROS2 to an ARM process? So I would think at this point, because it's using standard C++ and not a lot of boost, etc., that it should be easier than things in ROS1. I know right now that they are building debs for ARM in like ARM, I believe ARM hard float 64, don't quote me on it, there's too many different variants of ARM, but hard float 64 is actually a tier 1 support, I believe, which means that it gets the same level of build, and I'm getting the thumbs up from Rohan that, yeah, that is correct. It gets a tier 1 support for it, which means that it gets the same level of package build as a like Ubuntu desktop. So that's big. And I think, yeah, you'll find that works pretty well there. Seem like some of the Python snippets were more verbose or less Pythonic. Maybe. It could also be like, in terms of Python snippets being verbose, because I'm putting them in a cookbook, I am trying to be maybe more verbose than I need to be in some cases, just to make it easy to know what's going on there. Oh, and there's confirmation down here that OpenDDS is still maintained. And there's actually an email here to the folks at Object Computing if you need support, and that they are the ROS2 evangelists. So yeah, that's in the chat. Let's see. How would you report approaching the Nito or BotVac package? I think it should be pretty straightforward at this point because it is Python. I don't know how much it's evolved from the days that I wrote that, but actually the biggest challenge may be Python 3 support if it hasn't been updated for that yet, because I know there's a lot of like bit banging going, or not really bit banging, but there's a lot of byte manipulation, and strings versus bytes from Python 2 to Python 3 has been the #1 biggest pain in anyone's rear end in terms of like getting Python to work in Python 3.
Ralph Gnock added the URDF and basically put it all in launch files.
Yeah, but but the big thing would be like in the Python code, has it been updated to Python 3 to do all of the byte manipulation that's going on?
You're talking about your driver and the wrapper?
Yeah, and I don't know. That would probably be the biggest thing, is just getting it into Python 3, which is actually the same challenge you'll have going into ROS Noetic, because ROS Noetic is all Python 3. How interoperable can we expect things like Cyclone DDS to be with other non-open source, non-free DDS vendors? So in theory, they're supposed to be compatible because DDS is that common spec. In practice, there is a list of interoperability issues that are on the index.ros.org, but it's actually really small, and most of it tends to be around services. And so ROS services are built on, is my understanding is they're built on DDS services, which are their own whole thing. And that could maybe change in the future, even because like it's been the big problem along the way, right? And it's actually one of the big things right now that fast RTPS had a lot of problems with, especially when Foxy first rolled out. Some of that may be fixed. I'm not sure how well yet. So yeah, interoperability, I think at runtime. So I think at runtime, having multiple nodes that are running different DDSs communicating with each other is probably still not the recommended path, right? That said, if you develop something using Cyclone DDS and then later go and swap out your DDS underneath, you may need to update the XML file that's like configuring it or whatnot. But the upper level code, all the stuff above the RCL, right? All the things, or everything above the RMW rather, should not require changes at that point, right? But yeah, at runtime, combining different DDSs may not be great. Yeah, and I think I've actually hit the end of the questions in chat. So
very good, excellent, excellent. We have world-class presentations. We still have world-class presentations.
I think this is the first time I brought a robot to a meeting in a long time too. So, the going, remote actually works in my favor.
And oh, what a robot you brought.
Yep.
Very fine. Are there any more questions out there for Mike while we've got him here?
I'd like to ask a question. So when I first learned about ROS many years ago, it was originally supposed to be more of a definition of how robots would communicate and how the packets and protocols were set up. And then Willow Garage decided to build the whole thing on a Linux platform, and basically, in my opinion, it just became something that only Linux gurus could understand. And there's a lot of people that still feel that it's that way. And I totally applaud you for working with other operating systems. But now I went out and bought myself a Nano, and I've got the whole Isaac SDK, and it's a hell of an SDK. And all I really want to do is have it talk through DDS or some other dynamic protocol to my ROS system. So I kind of was hoping to see more of a VROS, which was basically kind of like what ARM does. ARM doesn't make processor chips. They just define the core. and everybody else makes the chips. ST Micro, blah, 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 blah. There's a bunch of manufacturers to buy the intellectual property blocks and make the processors. But basically what I was hoping that ROS2 would do was basically set the definition as to how all of these up and coming robot operating systems like the Isaac SDK could communicate with each other. But instead, what we've got is just trying to implement the communication stack over Ethernet and over Wi-Fi, again, to Linux primarily, and then a little bit of Windows and a little bit of whatever. And this is, again, I know I'm really not getting anybody, but I've been harping on this for 10 years, is that other companies like NVIDIA that are worth billions of dollars are going to create SDKs that are going to just put ROS in the dirt because they can create processors and fast code, and they can do everything that ROS does and more. But what ROS has, besides the fact that it's got a huge following, is the ability to create the protocol that everybody uses and the definition.
Yeah.
And I totally love what you've done with ROS2 and the dynamic data protocols. But again, I'm not seeing this as something I could port to even. I've got small little microprocessors that I want to just communicate with a ROS system.
Yeah, so there is a project, there's MicroROS, which actually is meant to run on microcontrollers, right? Because actually, I mean, it's built on DDS, right? DDS is a specification, right? Like it's not an implementation.
Right.
And then at the ROS level, there is significant documentation. I don't know if I'd call it necessarily a specification, but effectively that RCL library, right? Which is just pure C, like should compile just about anywhere because it's pure C, effectively implements the little bit on top of the DDS that you need to make that all happen, right? And so, connecting some other system into it, like if you've got a DDS implementation on your end and you follow those rules of like what the name resolution and those sort of things are, the IDL underneath, right, the definition language for the messages is actually not something custom. It's using DDS IDL, right? Like we have our own thing on top to basically make it use the ROS message style, but the output at the end ends up being DDS messages, right? So you could take those and migrate those over into some other system if you needed to.
Then why would I mean, I think there's, so in other words, if I get my Nano and if I load Isaac onto my Nano and everything, what benefit do I get for putting ROS2 on there?
Well, I think the thing comes down to it, and again, ROS2 is like ROS is not for everybody, right? Like when people have asked me like, oh, should I use ROS on something? It's like, what are you leveraging out of there, right? And a lot of it ends up being those higher level applications, right? So maybe if you've just got a Nano that's, I don't know what it's even doing at this point, right? But it may not be that there are applications that make sense for you. On the other hand, if you've got, a UR5 robot and you've got a depth camera and you're basically trying to put together a pick and place system, having access to things like Move It and the various perception pipelines that exist in ROS, those are valuable, right? And the visualization tools like RViz, right, are also very valuable. So yeah, I mean, if you don't actually see something in the higher level ROS that you want, then yeah, I don't see why you would connect to ROS, right? But I think there's enough people out there that see value in those higher level, the tools and the applications that they want to use ROS.
Don't get me wrong, I'm not dissing ROS. I'm just saying is that other big companies are coming along creating these fantastic SDKs like Isaac and fantastic systems that do a lot more, and they run through the GPUs.
Behind ROS too. If you, I mean, Amazon is very involved from the Amazon Web Services side. And so, they're a big proponent of ROS too at this point in a lot of different areas. So I think there's, there's big players in various different spots.
You're both making very good points, which I was trying to touch on with my question, which is the especially with like DDS coming from gigantic consortium like the Corba Group, which makes their money off of licensing large, huge software suites to large, huge companies, you know, are we going to be getting ourselves into a situation where if I have my proof of concept robot and hey, I want to make a product out of it, do I now have to pay $5,000 or $10,000 for a license to work with everybody else's
No.
system?
No, so there's no
And that's
licensing
a
around that.
huge question.
Yeah, but
You
I think
know,
that one's actually
is there going to be some key feature, some key transport? And we've seen this with like messaging and mail and things, which is why we still keep having like every 2 years you have a new messaging or a new video chat system. There is some key part of a spec somewhere that is actually not part of the free spec. That is part of the licensed patented spec, and that's where you
yeah.
you know have to pay. I
At
think now on the other side, I just want to finish this thought. On the other side of this, I will say that from my consulting, working with different companies with robots that are using ROS and not using ROS, the ones not using ROS, even some of the big players like KUKA and ABB, they have messaging ports into ROS. And they realize it's at least important enough that they provide some backwards, you know, some back compatibility or some, you know, cross-channel so that you can use some of the, you know, some of the raw stack. Anyways, you were going to say, Mike?
Yeah, so I was just going to say around that, like, I think with the technical steering committee that exists for ROS2, right, they're not going to let anyone sort of sneak required features like that in there because that undermines their ability to use the system, right? And so there may be add-ons that exist in some other system at some point that you may want for some commercial application, but I don't think you'll ever need that, right? I think where the commercial DDS implementations really come in is, say you want to go get a safety rated DDS implementation, right? Because you're going to do some safety rated aspects higher up in your system. That's where you would go buy this safety rated system. It's not so much you're paying for the software, you're paying for the effort that went into making that comply to some various safety certifications. And so I think that's one of the big things that, you know, would be the reason to use a non-open or non-standard DDS for various commercial systems. But again, at that point, if you're, you know, if you really need a safety rated version, like, you're going to go buy, you know, like, you're going to bake that into the cost.
Hopefully you have
Either
some
you're going to take the
funding
open
to buy it. Yeah.
Yeah. And so it's a trade-off at that point. But yeah, I don't think there's a risk here of needing to use a commercial DDS. I think that they are available for those who want it, right? And similarly, if you don't want to employ people who actually understand the inner workings of DDS in-house, the ability to buy a DDS license from somebody and basically actually have a phone number you can dial at, you know, 24 hours a day, 365 days a year, you're not going to get that with the open source, right? But you can, you know, do that sort of thing and have that phone number to call, which for certain large corporations is kind of a requirement to pick a software package, right?
Mm-hmm.
Like, it's largely why Red Hat exists, right? Is that because people wanted
they
Linux
totally
where they could call someone and get support,
right.
But that didn't make Linux that you had to buy it. So I think I would think about it more in like sort of the Linux Red Hat model is where these DDS implementations are going to come in. I guess we got a couple more questions that came in here while we were discussing that. There's some comments around the ROS1 to ROS2 bridge. I actually haven't used it. I've seen some comments that like it kind of works, but you know, it can be performance limited. And so like, depending on what you're putting through it, may be a challenge. I actually just jumped straight into all ROS2 and, you know, ported the robot over. One of the nice things right now is that you can have your same operating system and run, initially I was running 1804 with ROS1 Melodic and ROS2 Eloquent side by side on the system. And so I would just switch between the two. And then I ended up upgrading to 2004. And so I have Foxy and Noetic on here. And so I can actually switch back to ROS1 if I need to, mainly because I'm using this robot to test various software that I'm maintaining. And so it's really nice to be able to switch back and forth between the two. historically, there was a good interaction between autopilots and ROS1. Do you know of any efforts? I'm not too familiar with the autopilots like PX4 and RGPilot. I presume that they will end up having a ROS2 version, but I don't know when, right? Again, I think right now, like
on the
in
ROS
terms
side,
of
they just
do
look
they?
like a ROS node, so they should just work or basically be ported.
Right. The question is they had good interactions with ROS2. So whether they've actually been updated to have that, I don't know.
I don't know, but yeah, there's nothing special about it.
Right, right. No, I think it's, you know, ROS2 is still early in terms of adoption. And you know, and so, but I do think it's picking up. I think the challenge is that there's a bit of a chicken and egg problem of like, until it's tested on real robots, it's not great for real robots. And nobody wants to be the person to go in and test the thing that's not great on their robot. And so it takes people sort of jumping out there and working on it to make that move forward. Question here. So if I was starting a company today, like Unbounded, would you do ROS1 or ROS2? I would probably, so if I was starting something from scratch right now and you weren't on a bunch of legacy code, depending on what I was doing. So if I was in manipulation and I was trying to do something in manipulation, I need to use move it, I'd probably still be in ROS1. If I'm doing something, you know, navigation related or whatnot, or where I'm not going to use ROS navigation or whatnot, I'm just looking for like RViz and tools for, you know, build system and whatnot, I'd probably go with ROS2 at this point. And I wouldn't have said that 2 months ago, right? Like it took me some time to get to the point where it'd be like, yeah, like as long as the things you're looking for are ported over, there's pretty good coverage at the moment for things like Hikoyo lasers and SICK lasers, like particularly the companies that have been providing drivers for their ROS1 stuff have done a pretty good job of getting their ROS2 version out. So guys like SICK, so the Hikoyo one is actually community maintained, but the SICK drivers are actually provided by SICK themselves. They've done a good job of getting their ROS2 port out very early. Yeah, so I think it depends a little bit on what you're planning to use. Like, and if the things you're using are there, or I think it makes sense. I think long-term, even if they're not entirely there, the effort it's going to take you to port those things or make them work in ROS2 is probably less than the future effort that if you wait 2 to 3 years and then have a giant system in ROS1 and have to port it into ROS2, like that'd be, I think making the move for ROS2 right now, like with Foxy, I definitely wouldn't have said it with Eloquent, but Foxy, the latest release, I think you could go do that. And certainly if you're on an existing ROS1 system and it's working for you, maybe not the time to move to ROS2 quite yet. Like, particularly if you don't have the time and effort to apply to actually go through and debug those various issues around the edges. Okay, that's just a comment. So what is the first step for adding ROS2 to an existing bot? Yeah, you're definitely using the higher level, you're not really writing like a DDS publisher, right? Like you're going to use RCLCPP or RCLPY. And for the most part, like I still don't know most of the inner workings of DDS and I hope to never learn them. We'll see if that holds. You know, at this point, my knowledge of them is the half of the QoS parameters that I use. And that's why like the other 4, I ain't used them yet. So that's why I didn't describe them. You know, I think at that level and sort of, you know, I've done a little bit of, obviously, probably more than I needed to, but I was interested to look into the Cyclone DDS stuff in order to give a good recommendation to the club of like how we put a whole bunch of robots on a network. Because I don't know that that's actually a use case of like a whole bunch of systems that are not centrally managed, that are all on the same network, is probably not been very well tested yet, right? Like in most places, if they've got multiple robots in ROS2 sitting there on the network, they put them all there. And so they can properly namespace them all and not have them collide. We can't obviously do that with the club. So that tag, the domain tag is very useful. But yeah, using the higher level endpoints would definitely be like RCLCPP, RCLPY, converting the nodes you had in ROS1 into ROS2. Update your publishers and subscribers. Yeah, that's sort of the first steps in moving something to ROS2. There's a lot, if you sort of look at my GitHub, I have a lot of packages that I've ported. And so there's like a lot of examples there of Python nodes, C++ nodes, all of the lovely CMake that goes into it, and what that takes to sort of migrate those over. And so you can kind of get individual commits. I just ported over the weekend my simple grasping package, which does perception with PCL of basically segmenting the tabletop and the objects that are on top of it and generating grasps for those. And so I kind of put that all in one pull request that got merged into a single commit at the end. And that is like a line for line transition of a package into ROS2. And for the most part, it is a straight port with the exception of, I actually found that PCL ROS has not been ported yet. And so I can't like do the little bit of syntactic sugar where basically you subscribe and your callback is a point cloud type, right? You have to basically it's a sensor messages and use PCL conversions, which has been ported to convert it from a sensor messages into a point cloud and then convert it back again before you publish it, which honestly is all that's happening under the hood anyways, but it's not as clean in the code. Yeah.
All right.
Cool.
Is that it?
Awesome.
Out, Mike. What do we got? It's almost 1 o'clock, right?
Yeah, it's going on 1 o'clock. So, a little bit of a later night than usual, but.
All right.
Hey.
I'd like to thank you very much. Oh, the slide deck, can you post it to the mailing list?
Yeah, I'm going to PDF that and I'll post that up to the mailing list along with links to these different resources that I mentioned because not all of them are in there. So, yep.
Fine.
It'll probably be in the morning because it's a little late, but yeah, I'll get that.
I got the recording started a little late, but better late than never.
Cool.
And thank you very much.
Awesome.
We'll see you on the internet.
Yay.
Perfect prop there, Wayne. He's got his little unbounded cube.
There you go.
Yeah, I've got mine too.
That's
Somewhere.
That's the official block of the TableBot challenge.
Yep.
There we go.
We'll see a demo of the robot picking that up soon.
Yeah. I've had it working in ROS1 when I was testing everything out here, but obviously not quite in ROS2 yet. So we'll get there.
Yeah.
I still think that has to be one of the most epic Craigslist finds that I've ever heard of.
So good to see everybody.
I believe that was James Nugent that found it.
It was. Yep.
Was it someone who previously bought it or was it out of the storage locker?
It was out of the store. So it was basically, this was the guys, the story goes that the folks who took it through bankruptcy, right, they were able to sell off, the things like computers and chairs and benches and, test equipment and whatnot. And then they had all the stuff that no one wanted to buy, which was robots in crates. And so this was, they were basically, apparently they hadn't quite paid the rent on the storage unit or whatnot. And there were some issues there and whatnot. And so they weren't able to actually get to a bunch of the stuff. So there's still more unbounded robotics stuff out there that may show up on like Storage Wars someday. But
Whoa,
yeah.
I don't need to hear that.
Yep.
I know you talked about it on your blog, but just briefly, what was the state of the robot when you got it? Like how functional?
Well, so the batteries were 7 years old, so they were totally dead. Actually, I believe between the two of them, instead of it measuring 24 volts, it was about a half a volt combined. So lots of bad cells. So I got a replacement for those. Computer and all booted up. The CMOS battery is, or like the battery backup on the laptop, on the computer inside was actually still good. So like it still had its date and time and all, which I wasn't expecting. I'm pretty sure someone opened this robot up at some point because a lot of fasteners were missing, and it wasn't quite fully put together, and it was super, super dirty. So basically the first thing I ended up doing was really like taking all of the skins off, inspecting things. Also this one, it did not have the laser in it, because if I recall correctly, we had like a prototype laser loaned to us. And so we had to like remove that before we because it wasn't actually property of the company, so it had to get sent back. And so the laser had been like cut out of it, and like wiring was hanging around where like various tie straps had been removed. And so had to put a laser in, had to fix up a bunch of the tie straps and cabling around it. I recently, actually yesterday, had to replace the SATA cable to the hard drive, because basically it was like a non-latching one. It's been rubbing back and forth for a while, I think. And basically the robot wouldn't boot up yesterday. So that was bad. I had shut it down because there was like a whole bunch of lightning storms out here, and decided I'd fire it up early, because last time I had to fire it up for a demo, like I've been leaving it on because it wasn't firing up nicely each time, and I just hadn't debugged it yet. I showed the robot off at Bots and Beer with Silicon Valley Robotics like a month and a half or 2 months ago. And that time I started up 10 minutes before the meeting, and it wouldn't boot properly. And it took me a number of tries, and I actually ran it in ROS1 that night. Don't tell anybody. Like there's claims that I just ported to ROS2, and I did say that I ported to ROS2. I never actually said it was running ROS2 that night, because I couldn't get into the 2004 partition. Got it to reboot properly after that, left it on for like a month. And it turns out, and then basically the hard drive it couldn't find it anymore. And so I was like, okay, something's really wrong. So I had this at like 5 o'clock yesterday. There's actually a picture on my Twitter of like the skins are off the back. The computer's been pulled completely out. There's cables hanging everywhere. And I found the SATA cable was bad. So I replaced that, powered it up. Everything looked good. And so basically tightened all of that back up and put all the covers back on for today. But yeah, that's been pretty much the things that needed work. The computer booted up and was working there. I've obviously done a lot of work to update software to the latest versions and whatnot. Yeah. Cool.
That's awesome. Again, thank you very much. And
Yep.
everybody, we're a builders club, and I'm going to be bugging everybody on the list. I think everybody's seen your robot, but everybody's not seen your robot. And you have
I'm doing it.
What's that?
I'm doing it.
All right. Chris isn't still there with the ZenBot, is he? I'm ready to see that ZenBot. Say, Gertz, say something. Speak up. Chris Palmer, I want to see that ZenBot running next month. I know you're out there. Chris says he has no mic working, but he'll have version 3 of the ZenBot one day. The ZenBot. It's a quiet robot. All right. Dan, tell us what you really think. So, without any further ado, I motion that this meeting be adjourned. Do I have a second?
Second.
There we go. It's 1 o'clock over here. We have a second. All those in favor say aye. Aye.
Aye.
All right. Those who oppose, like sign. All right. That does it. So this will end the meeting. Good to see everybody. See you next month. And don't forget the SIG, the special interest group on the penultimate Wednesday. All right. Love
the meeting.
you guys later.